question says that glycerin flows steadily through a horizontal tube of length 1.5 meter and radius of cross section is 1 centimeter. If the amount of glycerin collected per second at one end is 4 into 10 raised to the power minus 3 kg per second, what is the pressure difference between two ends of the tube? So imagine this is a tube in which the glycerin is flowing from one end to the other, and the cross section radius is given, that is 1 centimeter, and the length of the tube is given, that is 1.5 meter, and the mass flow rate is given to be about 4 into 10 to the power minus 3 kg per second. So we have to find out the difference in pressure, delta P. Now we know that the Puzzle's equation says that the pressure gradient is equals to this expression where V is the volumetric flow rate and eta is the viscosity, length is the length of the tube, and radius is the radius of cross section of the tube. So we have to find out here volumetric flow rate in order to find the pressure gradient. So volumetric flow rate can be calculated from the mass flow rate by dividing it by density. Density of glycerin is given, that is 1.3 into 10 to the power minus 3 kg per meter cube. So volumetric flow rate comes out to be 3.08 into 10 to the power minus 6 meter cube per second. So using this we find the delta P, that is pressure gradient, and it comes 9.8 into 10 to the power 2 Pascal. The question also says that you may also like to check if the assumption of laminar flow in the tube is correct. So there is a dimensionless number called Reynolds number which is used to check whether the flow is laminar or turbulent. So if Reynolds number is less than 2000, the flow is said to be laminar flow, and the expression for calculation of Reynolds number is rho times u, that is the flow speed, and L is the characteristic length, which in this case is the diameter of the tube. Rho is the density of the fluid, that is the density of the glycerin here, and mu is the viscosity. So converting this expression for volumetric flow rate, we get the expression rho times volumetric flow rate multiplied with 2r divided by pi r square multiplied by viscosity. So using this expression we find out that Reynolds number comes out to be about 0.3. Since 0.3 is much less than 2000, so the flow is said to be laminar flow. Thank you.